Okay, it looks like we're good. Let me just check this, just make sure the stream is good. Mic is working. Okay, everything looks like we're doing good. Okay. Analytics. Okay. About that. Stream is healthy. We got a good connection. Okay, let us talk about what we're gonna do today. So today we're going to. I got the DVI working the other day. We can walk through that real quick. I can show you a few examples of the color, and then we're going to try to change the resolution of the HDMI port to support the camera. We want to look at maybe doing 30 frames per second. We need to figure out how we're going to buffer that with the camera. But we'll figure it out. We'll figure it out. Okay. I think that's good. Okay, it feels weird not wearing headphones, but I don't really have a reason. Let me open up the chat real quick. We'll wave. Set this up. Okay. So okay, we'll just ignore that for now. Okay. So yeah, today we're gonna go explore the video, explore playing around with resolutions on the video, and yeah, see how it goes. Something mostly informal. So yeah, back to our system here. Is that we have the DDR, which is using as a static frame buffer with a single image, is being transported over. Is transporting the image through the VDMA engine to this pixel unpack, where we go from 32 bits to 24 bits pixel unpacking, and then we send it to this DVI stream where we have 12-bit color, active, H-sync, and V-sync, and these values are defined through the AXI bus, as we'll see in a second. So let's go ahead and get this working. So let me go turn off the camera real quick. Okay. And we'll go to this hardware manager. The camera's going to be unhappy if I do that while it's running. Okay. Camera app is down. Okay, let's go open up and let's download the DVI design that we currently have. So we're going to send the DVI design. And we'll see it in a second. Okay. That black box right there is the HDMI screen capture, or the HDMI capture. So we'll get to that in a second. So let's go to Vitus. Vitus is configures the resolution and whatnot, and gets the frame in the correct location. So let's go ahead and run that. Okay, so you see the screen in the top left. We have the black circle with the blue screen. That is our HDMI capture, and we're going to load in some images. So currently we're going to load in some art that I've already pre-compiled from previous streams into some bitmaps. So we can go ahead and load that art into. I'll probably do my logo. I think that's going to be the back bin. We'll find out in a second. We'll let this load first. I might be able to increase the JTAG speed. Just see what the JTAG set up to right now. Yeah, let's see if we can increase the JTAG frequency real quick. So let's go into exploration about how we set up the JTAG, right? So if we do JTAG help, there's a no, help JTAG, right? There's a help JTAG, you know, frequency. So if we do frequency, right? Like, oh, you can do different things. So let's go list what's the current frequency. The current frequency is that. Oh, can you list what other frequencies we have? Oh, we can go much faster. So we want to go, that's 30 megahertz. Yeah, it's 30 megahertz. 30, 1, 2, 3, 1, 2, 3, right? Boom, let's go faster. And let's ls to see what other images we have. We're going to do the back bin. That's more appropriate. Let's see. Is the increased resolution? And look at that, JTAG much faster. Cool. We up the speed of the JTAG. Okay, so that is running at 1080p, 60 frames per second. So it's actually good resolution. Like we can increase this. Not what I wanted. We can take this and I can increase it, and you guys can see that it's a good resolution. Let's go ahead and pop another image in there, right? Let's do what we did, test 00. Yeah, that's a good picture. Colors, like those colors. And this is just 12-bit colors. It's amazing what you can get with 12-bit colors, right? Yeah, really hits well. Okay, so our goal from here is we want to try a different resolution, right? So we want to try to support the camera resolution. The camera resolution is 2304. So this right here is 1080p. Our 30 frames per second was, you know, like the 74.5 clock, I think. And 60 frames per second was at like the 149 or something clock. But we want to be able to do, let's copy this. We want to do a new system, right? We want to do 2304 by 1296. Right? And we're not going to do 60 frames. We're probably going to aim for 24 to 30 frames. We'll see which one has the better system. So if we go, let's see, if we take, let me make sure everyone can see what's happening here. So if we take this and stick this over on the side here and go pick out this tool right here, back here. We are currently running at 148. So we have an H blank of 280. Right, you can't really see it. But we have the front porch is 88, sync is 44, and the back porch is 148. And these numbers would match as well. D blank, oh, it's not 5, 4, 5. Yeah, 4, 5, and 125. So that's for 1080p. But we want to do a right. We want to do 2306. We want to do 2306, right? Or 2304 at 1296. And we want to do like a good. Let's pick a. Let's see if we can find 75. We don't have like a good DMT time, do we? Okay, yeah, sure. Won't give me those times, but yeah. Let's see, do we have a better clock we can use? Let's roll through the clocks real quick. 28, 29, 30. So yeah, let's do 24 and do for the 77.5. I like that clock. Let's see what clocks we can actually achieve in this system. So first off, let's save this as DVI 2304. I want to see if we can achieve this one. Also, let's go back to that 1080p preset, right? Which one's? That one's much closer. This one's wider. That's the timing that one used. I'm just not sure if it's going to work well. Okay, but let's go back to the diagram real quick and go to where our pixel clock is generated. Is this guy. See how well he can generate a 77.5 clock, because that was probably the cleanest. And then we'll see if the system works. So we're going to go to output clocks. How well can you do 77.5? It can do 77.5. So let's go ahead and build this and then work on the software why it changes. Okay. And we'll build that and we'll try to change out the resolution. Hopefully my system takes it well. Yeah, it's fine. Let's make sure the right resolution was used. Right here, 77.5. Okay. And then we're going to save this and then generate the bitstream. Okay. So let's go ahead and generate the bitstream. Yes. Okay. And we can probably run the previous one. It's going to be a weird frame rate, but it should still work. But let's go back to why this is running. And we want to do 2304, right? 1296 at 24 frames. We're going to do this guy right here. So H total is 2464. Front porch is going to be 48. Active is going to be 2304. Back porch is going to be 80. And sync is going to be 32. Be tight. VSync is 5. Back porch is 7. Active is going to be 1296. Front porch is 3. That is very, very small. And we'll have a 13111. I don't know why it says a blank duration. That must be something different than what I'm understanding. Yeah, those numbers add up to 160. Oh, it's because it's several like frames, I think. That's going to give us 23.9992 frames per second. Okay, so that should be interesting. We'll comment that out for now, and we'll run this. Go back to. Okay, we want to see this value when it gets to. If we set that to 30, right? 31. 32. 30. Got like a 74 there. So we're probably dealing with like 31 frames. Probably what we're going to get out of this setting with this system. How are we doing here? We got a few more things we're running. Oh, quite a bit actually. Okay. Well, while we're waiting, I guess we can go play with our shadow cache, right? Is there shadow cache? We can go through the images while we wait. I guess we can try to run the other one, right? We can try to run this at a faster clock. See what happens. Oh, we might need to reprogram it. Yeah, let's see what happens. Save sources. We want to Control B, right? Build. Oh, make this thing smaller. So make this guy small. See what's. Invalid suffix x. Oh. I don't know where that came from. Yeah, let's go ahead and run it. I may not be happy. Hey, look at that! It works. It's not happy with the resolution. Well, I mean it's off, right? So the frames aren't lining up. The data for the frames aren't lining up. Let's load an image. It'll be fun. It'll be terrible. Oh, look at that! We're slowly changing the image. Okay, let me go ahead and plug this into our system and see what resolution we get. Ah. So the casting's gone. This is going to go onto the other monitor, and I guess I'll show you once I get it working. What do we got here? Okay, seems good. That back around. Okay. Seems we're good to go. Let's go back. That's okay. Back to the hardware manager real quick. Let's go get the other one. And run the software. Okay. So we're going to have to get this working and then figure out. Okay, seems to be good. Now let me change this monitor to HDMI. Oh, I gotta plug it in. Okay. If you can see, right? So, if we look at info, it says it's we have a H of 60.9 kilohertz and a V of 47 kilohertz or 47 hertz. So that is basically giving us our resolution and frame rate. And since the new bit file builds, we should get a 24 here. We should see a 24 and not a 47. That may take a bit of time. Let's just view this auto-negotiating that. I want to read what's can we get the front panel I/O real quick? Can we look at the properties? Here it is. Okay. Let's see. We have the camera there, and we have the PMOD there. 180. That one's running at 330. Okay. Seems everything's going well. Oh, we can look at wires in. Ah. Interesting. I don't have the setup right now. Okay. Yeah, so I guess now we're just kind of waiting for this to finish, and once we got 24 hertz, we can verify that. But the next thing, right? So the next thing that we need to keep an eye on. Log. So the next thing we need to keep an eye on is how do we take the camera Bayer filter and translate it to this DVI port? I think we should be good. We just need to break it down to 12 bits. Yeah, it should work. Yes. There we go. we might just end the stream here because I feel like we've done it. I guess I'll close up by doing a we'll do a view of the different images we have. So let's get JTAG plugged in. Make it a mount for this guy. So let's go back to Vitus. Whoa. That Control B to build it. Okay. Oh. Let's try to put guy in there. Oh, yeah. So what's the shadow cast look like? Is this actually running? Okay, let's try this again. Program the device. And launch this guy. Shadowcast not working. It's working over here. So let me see. Do I need to let me reset it? Okay, close. There we go. It's streaming properly. Yeah, let's go ahead and do two. We already saw these other ones. I'll keep an eye on the build to see how it's finishing. And we'll just go through some of these pictures. Oh, we're getting close to route. So, progress. Okay, there's one picture. Let's go ahead check out the next picture. What's that's a famous painting. I can't remember who's. I need to find all the sources for all these pictures. Okay, what's next? Routing is done, so we should be done good soon. We can try this new bit file. We're gonna have to turn off, plug in the other HDMI real quick. And then we can check the system. Yay! Look at that. Wish we had like an input HDMI. Let me go figure out if where is it. Input HDMI. I think this is the only PMOD HDMI system that exists. Okay, how are we doing Bitstream wise? Close. Not close enough. That's interesting. Ah, this picture. This is a one picture. How are we doing here? Okay, it's almost creating the bitmap. Do one more. Oh, you wait. Never these. Yeah, I should remember this one. Okay, BitGen is complete, so we can try out the new image. And it's still taking a second, so we'll go ahead and try 11. 11's a cool one. I think 11's the last one. Might have more. Oh, we have one more. 12. Do 12, I guess. Nice picture. Okay, this is all our test pictures. The Bitstream is done, so let's go try this other one. So what we're gonna do is we're gonna turn this guy off real quick. We're going to plug in the HDMI cord we have. It's just that hard to get this. Okay. Okay, we're running. Remind me later. Okay. Now we're going to program it with a new one, which is going to be the one with the funky name. Where do we save? We saved this under OK Camera Vivado. This is OK Camera. This is a weird place. HDL. SYZYGY Camera. Vivado. Apparently we saved it there. Okay, runs. Station. Popped it. Okay. Okay. So we're gonna program this one, and then we're gonna try the. Oh, you guys can't see a thing. Turn that off. Okay, you guys can see now. So now we're gonna go back to Vitus, and let's go try the. We want to try the more fancier complication. The camera resolution at 24 frames. And then we're gonna run this, and then I'm going to see it on the big screen here, so we can see what the refresh rate is. Okay, it's good. Let's go try out the HDMI port. It's gonna look nasty. Okay, cool. Ah, that's great. So if we head over to information, right here, the top right corner, that we're running at 31.7 kilohertz H rate, and the V is 24. So we're doing 24 frames per second, and now we just have to somehow, I guess. So the next video in this series is we're going to take the camera output and we're going to stream it to HDMI, and hopefully that goes well. Can we do it while we get stream out from both of them? I think so. Yeah, we'll have to figure it out. Okay, well, that's not fun to watch. Here, put that back on the FPGA. So I think that's going to be it for the stream today. Yeah, we were able to get the correct resolution going. So the camera resolution will work. It will also work with the shadow capture if I can get that to work again. So we will try to capture over HDMI next time to see if that works. And I'll test the other captures. But yeah, join us later, maybe tomorrow, maybe Saturday. We're going to look at getting the HLS kernel working on the camera input.